Okay, let's jump right into this urgent explainer. Today, we're examining the severe physiological impacts of industrial gel diets on strict aerial insectivores. We're looking at a really fascinating but honestly deeply concerning intersection of wildlife rehabilitation and nutritional biochemistry, specifically focusing on birds like the common swift. Now, this question right here forces us to confront a potential wildlife rehab crisis head on. For years, incredibly well meaning rehabilitators have relied on processed soft gel substitutes, like those commercial insectivore gels, to feed injured or orphaned birds. But if we look strictly at the biology, we have to ask a tough question. Are these artificial diets actually saving them, or are they causing this silent, catastrophic harm from the inside out? To figure this out, we're relying entirely on a really rigorous technical positioning report by Enrique Fuste. He's a biologist with an MSc in wild animal biology from the London Institute of Zoology and the Royal Veterinary College, as well as a member of the Royal Society of Biology. His deep clinical credentials ground this entire investigation, and in his report, he presents 8 essential technical questions and clinical foundations regarding the risks of these processed diets. Our clinical roadmap today covers 6 key areas. 1. Introduction to the common swift. 2. The danger of sugars. 3. Mechanical and digestive failure. 4. Vulnerability and false nutrients. 5. Weak feathers and catabolism. And finally 6. Clinical risk matrix. Section 1. Introduction to the common swift. So the common swift, or Apis apis, is a total evolutionary marvel. They are strict aerial insectivores. That means they're highly specialized biological machines designed strictly to process whole insects caught on the wing. Because of this incredibly rigid evolution, they have absolutely zero physiological flexibility. None. They simply cannot adapt their intestinal biochemistry to diets outside their evolutionary norm. They are completely unadapted to starches or complex sugars. Section 2. The danger of sugars. Fristy poses a really critical question here about a completely contradictory practice. Just imagine a rescued bird arriving in acute dehydration and hypovolemic shock. Many industrial gels are packed with dextrose, which is a highly hyperosmolar simple sugar. So why on earth would we feed such high sugar concentrations to a profoundly dehydrated animal before its blood volume is even fully restored? Well, here's the problem. That sugar literally inverts the intestinal osmotic gradient. Because the dextrose far exceeds what the gut can actually absorb, it pulls precious water right out of the bird's bodily tissues and into the digestive tract. This triggers a fulminant osmotic diarrhea, which rapidly accelerates renal failure. And on top of that, introducing simple carbs to a starving bird causes this massive insulin spike that drags electrolytes straight into the cells and causes what we call refeeding syndrome, leading to the rapid death of the patient in just a matter of hours. And that perfectly illustrates the next major issue: maltodextrin malabsorption. Insectivorous birds entirely lack the maltase enzyme required to break down complex sugars in their intestinal brush border. So what actually happens? The maltodextrin travels all the way to the hindgut completely intact. This undigested sugar creates the perfect incubator for lethal pathogens. It fuels an exponential overgrowth of E. coli and Salmonella, effectively destroying the bird's enteric immune system, simulating an avian inflammatory bowel disease, and totally blocking the absorption of vital calcia. Section 3. Mechanical and digestive failure. Check out this number: 60%. An insectivore's gizzard absolutely requires the hard, mechanical friction of whole insect exoskeletons just to maintain its muscle tone. When you feed them a soft, paste-like gel, there's zero abrasive resistance. Because of this, the bird suffers from severe gizzard atrophy, literally losing up to 60% of its mass in just a few days. So when that bird is finally released and tries to hunt wild beetles, its shrunken digestive tract won't even have the strength to crush the exoskeletons. It leads straight to fatal gastrointestinal impaction and post-release starvation. Let's compare the commercial myth of easy digestion to clinical reality. Manufacturers love to claim gels are great because they digest easily, but Fusteo's report points out that for a specialized bird, this lack of physical resistance completely wrecks their digestive motility. The hard exoskeleton of an insect naturally regulates transit time, allowing for proper acid exposure. Soft gels? They just slide through the gut way too fast. This rapid transit bypasses essential enzymatic and hormonal feedback loops, meaning the stomach and liver aren't stimulated properly, resulting in disorganized transit and massive chronic malabsorption. Section 4. Vulnerability and false nutrients. This slide highlights a really stark contrast.
We're talking about non-adapted fats and proteins. Feeding refined plant oils like sunflower or linseed alongside flowers made from terrestrial mammal byproducts to a bird that evolved solely for insect lipids is insanely dangerous. This alien amino acid profile forces the bird's body into an extraordinary catabolic effort. It drastically increases kidney filtration rates and causes acute renal stress. Plus, these abnormal plant fats alter the bird's lipolysis, leading to hepatic steatosis, which is a fatty liver, and actually changing the composition of the oils in their feathers, ruining their natural waterproofing. But hey, what about gels that use insect-based flowers? Well, FUSDAY shows us exactly how industrially milling these ingredients destroys the physical chitin prebiotic role. In nature, intact chitin reaches the hindgut and acts as a vital natural prebiotic. It feeds beneficial bacteria, which then produce short-chain fatty acids like butyrate. Butyrate is the metabolic fuel that tightens the cellular junctions in the intestine, literally blocking systemic infections. Grinding up the insect removes this biomechanical structure, stripping the bird of its primary defense mechanism against pathogens. Section 5. Weak feathers and catabolism. Growing swiftchecks need massive amounts of highly bioavailable taurine for their heart and eyes, and sulfur amino acids to build strong feathers. Because artificial gels often suffer from incredibly low bioavailability of these real nutrients, the chick's metabolism basically panics. It initiates a destructive deamination process where we see severe muscle catabolism affecting feather keratin synthesis. The bird literally catabolizes or eats its own pectoral flight muscles just to survive. This severe malnutrition causes a surge of the stress hormone cortiscotonin, which completely halts keratin synthesis. The tragic result: fatally weak, keratin-deficient flight feathers that will simply shatter under the extreme aerodynamic pressure of high-speed flight. Section 6. Clinical Risk Matrix. This risk matrix undeniably proves the compounding dangers of all 8 clinical points we've discussed today. Every major component of these industrial gels triggers a distinct and devastating physiological collapse. Dextrose causes fatal osmotic diarrhea. Maltodextrin malabsorption fuels deadly pathogens. Milled soft flowers destroy digestive motility and causes 60% atrophy of the gizzard. The loss of the physical chitin prebiotic role leaves them defenseless against infections. And those non-adapted plant oils and mammal proteins ravage the liver and kidneys, ultimately driving muscle catabolism that ruins feather keratin synthesis. I'll leave you with this stark reality. Now that we understand the deep biochemical contradictions mapped out by FUSDAY's rigorous clinical foundations, we have to seriously rethink how we rehabilitate these specialized creatures. Knowing all this, can we ethically continue feeding them processed gels? If our goal is truly to save them and return them to the wild capable of actually surviving, we have to respect their uncompromising biology. Thank you so much for joining me for this explainer, and keep questioning what you know.